Hey, so translations. This is one of the units that students love every year without question. It's much more conceptual and it's visual and it's less mathy. So people tend to like it. So here we go. A transformation is a change in a figure's shape, size, or position. The new figure is called the image. One type of transformation is called a translation. A translation is a slide. It can be up, right, down, left, any of those, or it can be a combination of those. It results in congruent figures. So when you translate something, it doesn't change size or shape, and it cannot be flipped or turned. So it's like if I had something on the table and I just slid it over to you, it would stay the same item, same size, same shape, facing the same direction. It would just change its location. So this thumbs up shifts up and to the right to become this thumbs up. That makes this one the original and this one the image. And I went up and to the right. This musical note, not a note, I think it's a staff, but I'm probably going to be wrong. Somebody correct me on this one. This one is sliding from left to right. So I went right only, not a combination. This one is my original. This one is my image. Original is exactly what it sounds like. It's the one you start with before you do anything to it. Does each pair of figures show a translation? So on this one, the baseball bat changed size. So we would say no because it changed size. The glove, we would say that this is not a translation because it was rotated. It turned. And then this baseball, same size, same shape, same lettering, everything is right. We could either say it went down to the right, or we could say it went up to the left. We don't know which one is the original and which one is the image. So at this point, we can just say that yes, it's a translation, but we're not sure which one's which based on the information given. Translations can also occur, excuse me, in the coordinate plane. Which figure is the original? So if we look over here, we've got a triangle with a capital letter A, and there's like a little tick mark in the upper right-hand corner. It looks like an apostrophe. And this shape has an A, but it does not have that little tick mark. So triangle ABC, this one is the original because it doesn't have that little tick mark. Triangle A prime, B prime, C prime, this one is the image. And we know that because of that little tick mark, that little sort of apostrophe in the upper right-hand corner. So to get from the original to the image, I would pick A and A prime. You could pick B and B prime or C and C prime. In order to get from one to the other, I had to go left 1, 2, 3, 4, 5, and up 1, 2, 3. So it would be left 5 units, and it would be up 3 units. So that would be a verbal description of the translation or translation in words. The congruent statement, what we're saying is triangle ABC, the original, is congruent. It stayed the same size, same shape as triangle A prime, B prime, C prime. So what happened to the coordinates? So the original coordinates of A were 2, 3. The original coordinates of B were 2, -2. And the original coordinates of C were -1, -4. Once it shifted to its new location, A prime is -3, 6. B prime is -3, 1. C prime is -6, -1. How did the x value change? So the x value being the first coordinate, how did the x value change? The 2 became a -3. The 2 became a -3. The -1 became a -6. So to get from the first x coordinate to the image x coordinate, we had to subtract 5. Subtract 5. And then from -1 down to -6, subtract 5. So that's what caused our shape to move left 5 units. The y coordinate, or the y value, how did the y value change? I went from 3 up to 6. I went from -2 up to 1. I went from -4 up to -1. So for each of those, I had to add 3, add 3, add 3. That's what caused it to shift up 3 units. I don't know why I put parentheses around that one. But the left 5 units, right, it happened to the x coordinate. So we would say it was x minus 5. And the y coordinate went up 3 units. We had to add 3, y plus 3. So if we were going to describe the translation in coordinates, we would say the x coordinate was subtracted by 5, the y coordinate was added by 3, and that's what gave us the new coordinates. So up here, left 5 units, up 3 units was describing it in words. Here, x minus 5 is describing the left 5 units. Y plus 3 is describing the y moving up 3 units. So translations. If you're going to move right or left, something has to happen to the x-axis, which makes sense. The x-axis is a left to right or horizontal axis. If we want something to happen to the y-coordinate, or if we want it to move up or down, we need to add or subtract to the second value. So use coordinates to describe each translation. 2 units to the right. So first, I'm thinking left and right is on the x-axis. So the x-axis to the right is positive, so I'm going to add 2. And nothing happened to the y, so I'm just going to write y. I didn't do anything to it. I didn't add to it. I didn't subtract. It didn't get bigger. It didn't get smaller. Now, technically speaking, when we write this, we're saying the original coordinate x, y becomes the image coordinate x plus 2, comma, y. Now, this is actually saying we have a point on the original shape. It becomes the point on the image. And what did we do to get it? 1 unit to the left. So the x-axis is left to right. So on the x, we would do minus 1 because moving to the left is negative. The y, 3 up, y plus 3 because up would be positive. So the original point, xy, becomes the image point, x minus 1, y plus 3. And last but not least, 3 units to the left. So left is on the x-axis. Moving to the left is negative, x minus 3. And the y, 4 units down. Down would be subtract. So the original coordinate P, which has xy, would become the image P prime, x minus 3, y minus 4. Describe the translation of the point to its image. So what's happening? If I go from 4, 1 to 1, 3, what is the translation? What's the shift? Now the translation, if you see the word translation, you should be thinking shift. You should also be thinking addition or subtraction only. So 4 to 1 means that I had to subtract 3. So my original coordinate becomes the image coordinate by x minus 3. And then 1 went up to 3 for the y coordinate. 1, if I add 2, so y plus 2 would give me the new y coordinate. Now in words, if the x coordinate was minus 3, that would be left 3 units. And if y went plus 2, it would be up 2 units. And this particular one said describe the translation. It didn't say whether to describe it as a coordinate or describe it in words, so I did both. -4 down to -9. So the original coordinate, I went from -4 down to -9. So in order to get the image, x would have to be minus 5. That went down 5. And then -2 up to -1, the y coordinate would be plus 1. So that would be minus 5 would be left 5 units. And plus 1 would be up 1 unit. And sometimes, like in the example, you might see something like 7, 3 becomes 7, -3. Notice the first number didn't change. 7 stayed a 7. So in that case, the point xy, we would say, well, when it becomes its image, the first coordinate didn't change. I didn't add or subtract anything from 7 to become 7. And then the second one, the y coordinate, 3 went all the way down to -3. I'd have to subtract 6. So it would not go left or right. It would only go down 6 units, and you wouldn't describe a left or right shift. So tessellations, which are at the bottom, are real-life examples of translations. A tessellation is a repeating pattern of polygons that covers a plane with no gaps or overlaps. So you can think about a brick wall. This pattern is often used in backsplash tiles in the kitchen and floors of bathrooms. And then this one over here is created by M.C. Escher, who was a famous artist who really focused on tessellations, number one, and drawing things that were impossible to create in real life. And this is an Escher design. So what are some real life examples of tessellations? Bricks, tiles, like shower tiles, floor tiles, backsplash tiles. Another one that you would probably recognize would be honeycomb. If you've ever seen honeycomb that bees create, sometimes you see it on things like wallpaper. You might see it on a border, like at the top around the edge. If you have a house that was maybe 80s, you'd see that a lot. Also, you see tessellations a lot in like wrapping paper, and there's lots of others. Hopefully, somebody can give me some I missed.